Good morning, good morning, good morning. Who is on? Good morning, good morning, good morning. Buenos dias. Papsi Dapsi, ready for exam tomorrow? Jose, you got jokes. What do you mean relying on you to... I have taught you a lot of things, Jose. Morning, Mr. Fair. Welcome. Jose, you're joking. You can't start study computer science this morning with the volume and notes that's there. Unit Module 2 and Module 3. The notes for those heavy. Lord have you. All right. Let's see what we can get done. We probably have to break this session into two though. So we're going to rejoin later on because I have something to go and do. So we will do this part and then rejoin later on just to wrap up some stuff. Yeah. So we can summarize later. The Unit 1 paper was good. So if that's anything to go by, we can always hope that, Unit 2 is good as well. They did minimize the value for the sections. I'm not sure if they're going to do that for, yes, I don't know if they're going to do that for Unit 2. Yes, I completely belong to you guys today, but kindly remember that I have to eat as well and so forth. So that's why I'm saying we're going to do this session and then break and rejoin. Not no hard. All right, let me know how the image is looking for you. I think it is small, but I don't know how to zoom it. Let me see. I'm not seeing any zoom in function. Oh, there it is. All right, so that should be better. If it is going to be blurry, but what you can do is to change the quality of the video. So let me know if it is that you're seeing it much better now. Change the quality and then let me know. Better now, Jackson? Where's Justin? Checking on something, guys. All right. Ready like Freddy. Yo, the time is so hot. All right, good. So, Justin, are you here? You know, so Justin want to beaten. Sure. What's up? All right, let us start. So we're looking on last year's paper. So while it is that we're doing that, we will be touching on some notes where applicable. So last year's question, as I, you know, for module one is going to look. It's a very short module. It's going to look on ADTs, different ways by which you can search and sort. There's a video on this channel for that, for searching and sorting. So please review that if you haven't. And that's it for these for module one. So it's pretty short, and what you need to know for the different ADTs are the different algorithms and functions in C. How it is that you would implement those in C. Um, and the basic concept of it. So here it is saying now that with the aid of a diagram, provide a detailed description of a linked list. So when we were looking on linked lists, you're basically going to draw boxes, and you will have to ensure that you label the head and you label the end once it is that you're doing that. What you would get marks for is the labeling the head of the linked list, labeling the null section of the linked list, and ensuring that you have nodes which is showing how it is that the linked list would look. So it's not, you don't have to draw anything extensive. So let us try that. Let's try drawing a box here. So for linked list, we know that we divide in two, right? So we're going to draw some boxes. Let's draw 4 boxes. And for each box, you divide it in 2. I don't want tables. Hold on. Uh, all right. So when it is that you have these now, you have to ensure now that you show the first part is always going to hold the data. Right? So if I put 2 right here, 2 is the actual data that is being held. And if I put 7 here, 7 is the location for not for number 2, but for your next data. Right? So here, if I divide this one in 2, don't ask me why it is that this thing is turning into that. And I don't. All right, hold on. Excuse the ugly drawing. So if I put 6 here and I put 1 here, so 7 is the location for 6, right? Come over here, do the same thing, divide this box in 2. And because this is giving me trouble, at some point in time, I just go and leave it. Let me draw one more box and then that's that. All right, we're going to use that one. Right? So 7 is the address for number 6, right? 1 would be the address for the next set of data. So if I put 25 here, then 1 would be the location for 25. And then I'm going to leave this blank, right? So this part, you label this part. This part is your data. And then you also label this part as the head. Right? And then you draw arrows connecting. So that's one way you can represent that part. That's one way. Let me show you the next way that you can do this one as well. So I can draw the same 3 boxes. In the name of the Father, the Son, and the Holy Ghost. And let me put this back here. So, all right, good. All right, so I'm going to draw 3 boxes again. And hopefully they don't turn into tables, but if they do, that's fine. I'm going to space these out more, since as that's what they are doing. All right. So for my 3 boxes, bear with me on this application, guys. It is going to give me heartache today just because of the drawing aspect. And there's no way to incorporate shapes in this, so I just have to make do. All right. So the next way we could do this using the same set, we have 2 here, so which would be the data. Then you draw a dot and you draw an arrow pointing to the actual data that's here. Use a different color. So you put 2, then you put a dot, and the dot will have an arrow pointing to the next data. The next data was 6, right? And then you have a dot pointing to the next data, and the next data was 25. So that's how it is that you can represent that part. Any questions on this part? Any questions here? All right, so the numbers, you would make it up. You don't have to use numbers. You can use letters, you can use words, whatever it may be. So you would find that you would create that data once it is that you draw the boxes, right, showing the linked list. All right, so the last part is blank. Let's go. How it is that data this particular ADT is, right? You have data, these are the data. You have the data and you have the location for each, right? Good. So when you see 2 right here, because it is the head, you're not seeing the location. So basically it's in location 1, right? 7, which is or in this case 7, which is the second part, is showing the location of the next data. So if you get a rectangle, or if you have a rectangle that looks like this, the first part holds the data, this side holds the data, and this side holds the address of the next data. That comes in the line. So 7 now would be the location where I can find data 6, where 6 is stored, right? 1 now, so that would be 2 and 7, right? The next box, the next box has 6 and 1. So 6 now would be the data, right, which is stored in location 7, and 1 would be the address for 25. Because there's no other data in the list, we leave the last section for the address blank because we don't have a next value or number or character being stored. All right, that's clear. All right, good. Now, the next part says that you are to provide detailed description. So it's with the aid of a diagram, provide a detailed description of the linked list. Because the lines are there, it is basically asking that you provide an explanation as well for what it is that you would have displayed using the diagram. The question itself, in terms of how it is structured, doesn't necessarily give you that indication, but that based on the marks, you would have to provide some details. So you would write, what is a linked list? So we know that linked list is a linear data element, right? Um, that holds nodes with nodes, right? Each nodes comprise of 2 elements. So this rectangle here is a node, and it contains 2 elements, which would be the data and the address. The address can also be known as the pointer to the next node, right? That is why we have the arrows here. So the pointer to the next node, or the address for the next node element, right? And you ensure that you speak about the head and you talk about the end part, and that would give you your full 8 marks. Ah, Who said them not study? All right, so let me clear this now so we can move on to the next question. All right, so for section A, you should be able to maximize your marks here. All right, let me zoom in. All right, so still on question 1B, question 1. It says now a stack and queues are popular ADTs. Define each of the following. So head to the chat now, guys. Stacks and queues, what are those? Use real life example here, analogies, and that will help you with that part. What is a stack? What is a queue? What is a stack? What is a queue? All right, stack data enters and exit from the top. So we have 1 point of entry and we have 1 point for exit. Which method does it use, Jose? Please ensure that you add that to your description as well. No, those are the operations. Those would be the operations. If you're going to take data from the top and you're also going to add data to the top, which method is that? Nobody responding? LIFO. It's not last in, last out. It's last in, first out. AKA LIFO. Right. Please ensure that you remember that. So this stacks would be a ADT. So it's a container basically where it is that you're going to insert and remove data from the top, right? Which is where you would explain that it uses the last in first out method, LIFO, right? All right, let's move on to queues now. So we know that for our stack, so this is going to be our container, right? And we are going to add one item here, one item here. So first in, last in, would not be in this case. So this one would be the last in and it would be the first to be removed because there's 1 point of entry and there's 1 point for exit, right? So if it is that I want to empty this stack and put it into a next one, I will have to remove from the top. So I'm going to move the top one here, bring it down here, remove this one, and then bring it here. And it will continue until the stack gets empty. So last in, first out. All right, what about queues now? And queue would be the same thing as relay. So therefore you just use that and run with it. So what is it? Queue inserts data from the rear, removes data from the front. All right. Yes, Jose. And it uses the first in, first out method. Ah, very good. All right. Big up you, Jose. Same thing as FIFO. Yes, first in, first out. Ah. So a queue is a line, right? So you are this individual right here is going to be our cashier or a server, and we have a line right here. So when you enter, you are going to enter along the lines here and you're going to enter right here. So the first person, this is the second, this is the third. So we have, right. So the first person in the line will be the first person to go to the individual and be removed, right? Because that first person joined. So you're going to, means now that you're going to enter from the rear, but you're going to exit from the front. Are we clear with that? And it's 1 mark each for this one. We're good? No problem. The blank paper? Okay, good. Are we as clear? Uh, Let me try and find it so I can send it now. Oops. Ah. All right. All right, so we can move on now, guys. So part 2 now. Part 2 says, state 2 conditions that must exist for the successful execution of the insert and delete operation as they relate to stacks and queues. So it's 1 mark here. So when it is that you are inserting into a stack or you're inserting into a queue, what rules should we apply? When can we insert? and we looked at this. When can we insert? The push, the pop, the push and the pop would be the operation, and the req, the NQ is not req, is NQ and DQ. Those are operations, but it is asking now in terms of you pushing, right? Same thing as the insert. If you're going to push, what it is that you are going to check for first, not the data, because you have the data. But let's say you have a stack. Let me see if I can give you what it is that it is asking for here. So you have a stack. That's a stack right here. We have item, we have item, we have item, and we have item. What it is that you're going to check for before you add data to this. So no. When it comes to insert, so for the insert, you must check first if it is that the stack or the queue is full, because none of the ADTs have boundless or can contain any amount of data. You are always going to tell the system how many data it is um you want to store. So if you leave it and you say 5, I have entered 4 here, so I can hold one more. I can insert an additional one, right? But once it is that I insert that additional piece, it means now that my stack is full. So before it is that you can insert to a stack or a queue, you must first check to see if the stack is full. And the opposite would go now. So before it is that you can delete, as Jackson would have said, the first thing you would have to do is to check if the stack or queue is empty. What would you be deleting from? You can't delete something if it's not there. So I'm going to tell you to delete 25 from the stack or delete 25 from the queue. But the stack, both stack and queue, they are empty, blank, waste of operation. Good. So that is what this question was asking, and then you would structure that in sentence form. All right, so let's look on part C now. All right, let's zoom. All right, so for complete the table below. All right, adjusting yours. So that is correct. So you check if it is empty or full. But you have to write it. You have to write. It's 2 marks, So for the insert part, right? So it asks about insert and it asks about deleting. So for the insert part, you would check to see if it is that the stack or queue is full. That's what you would do for insert. And then for deleting, you would have to check if the stack is empty. So that's the 2 part for you to get the 2 marks. So if the stack or queue is empty, you cannot delete for it. So the first thing you would do is to check if the stack or queue is empty. Before it is that you can insert, you would have to check if the stack or queue is full. Okay, Nintendo gamer. Ah, good. So looking now, is this blurry to you guys? All right, so let me read now. So it says that complete the table below by stating whether a stack or queue data structure should be used in each of the following examples. So for the first one, so I need your full participation here. Let me know what it is that you would write so that I can tell you whether or not it is correct or incorrect. So the first one, to store, undo, redo operations in a word processor, stack or queue. First person to get it right, get a pops tomorrow. Store, undo, or redo operations in Microsoft Word. Stack. Come through Jose with the right answer. All right. So Jose for the win there. One pops for Jose. All right. So this one is stuck. All right. Second one now. Second one says implement the printer spooler so that jobs can be printed in the order of their arrival. What is 9? How you give 9? Yeah, stacks are queues. So implement the printer spooler so that jobs can be printed in the order of their arrival. It's basically the whole aspect that manages the printer so that it is that the jobs will be done in the order it was received. That's supposed to give you the answer. All right. Yo, Jackson on a roll. Let's see how Jackson said him not studying. The answer is Q. Oh, that's what Justin. I don't know. All right. Next one. Implement a back function in the internet browser. Implement a back function. Nice. Implement a back function in the internet browser. Stack or queue? Stack again. All right, that's correct. So that is indeed correct. Stack. All right. So the next part here. Stores customer order information in a drive-through restaurant. Stores customer order information in a drive-through restaurant. This is 3 pops that may have for Jackson. All right. So you have to think about containers basically, right? So remember, this is a stack. This is a queue. Oh, good. Justin. All right. So with you using Microsoft Word, right? If you type 643 and you select undo, right? You select undo. Undo is going to remove 3. So if I put 3 here or I put 3 here, and then you undo again, 4 is going to come here, 4 is going to come here, 6 is going to come here, and 6 is going to come here. That is if you select undo. But then now you realize that, hold on, but these are the numbers that I want. So with this stack, if you select redo based on the operation, right? 6 would come out first, then 4, then 3, because it uses the last in first out method. But if it is that you are supposed to read the queue, what you would get is 3, 4, and 6, because it is first in, first out. Get it, Justin? Justin, got it? All right, so I don't know where Justin gone. All right, so that's the rationale for the first one, right? And if in the exam you have to do something that's practical, do it like that so you get the full gist of what it is that you have to do. Now with the second one, um, it would be the opposite of that which I just did. So think about it like a line in terms of you getting served, right? So Justin joined the line first, Jose joined the line next, Brevet joined the line, Tajmar then joined the line. So Justin is going to get through first, then Jackson, then Brevet, then Tajmar. But if it is that we were using a stack, Justin, having been entered first, would that be at the bottom of the list. Then it would be Jose, then it would be Brevet, then it would be Tajmar. So in this case, when it is that you're ready to be served, right, Tajmar would be served first instead of Justin. So you have to just align it in terms of the two and the practicality of it. So let's move on now. It says store customer order information in a drive-through restaurant. So think about you going through KFC line now. So when you're going through KFC line, using the very two examples that I would have used just now. So Justin joined KFC drive-through first, then Jackson, then Brevet, then Tajmar. If it is that you use the queue, then when it is that you reach around to the section where it is that you have to collect, Justin would be served first. But if you are using a stack, Tajmar would be served first. But Tajmar never ordered what Justin order. So then the whole entire order would be mixed up. So for this one, it is a queue. All right, so for the last one now, store incoming calls for a customer service hotline. So you call Digicel, you call Flow, and you're in the line to speak to the customer service rep. Which would be best to utilize? Would it be a stack or would it be a queue? Let's hear from you. Hey, you're right. Me actually owe you 4 pops tomorrow. Yes, Q. Justin, please don't go in the exam tomorrow, go right shorthand. But yes, Q would be the answer. All right, so that's that for this question. We can move on. All right, good. All right, so here, no. Let me see who is going to get these parts correct. All right, so write C code for the pop stack operation where the stack is implemented as a fixed size array. Present your code as procedures such that the stack array stack is accepted as a parameter. Assume that a global variable is used to track the top of the stack that is initialized to -1. All right. So first thing you're going to write is the data type for your stack. All right. So I know I'm going to have int and I'm going to name my stock. So this stack, the name of it is pop because that is what we're doing. And it says that we should have a stack array, right? So we're going to have int stack or square bracket and the size of our array. Now it says that is accepted as a parameter. No, hold on. A fixed size. So we don't know. So that is why we're going to leave this array bracket here empty. We're good here? You have it. You have the content, Mr. Jackson. You have the content. Kindly use it up. So is where the thing gone? Okay. So int pop, because that's a data type, right? And guys, you do have this part, so make sure that you utilize it, right? Because the algorithm, I'm sure you're going to get algorithm and you're going to get a function to write for one or the other. And it's basic. So you have the integer that is the data type, the name of your function, and in this case, it's best to name it that which you're doing. So if you're pushing, name it push, right? You're popping, if you're deleting, you're deleting. Name it like that and you follow the instructions. So it says a fixed size. So because it's a fixed size, that is why we don't put 5, we don't put 10 in this bracket here. So this is saying that stack is an array and this is the data type of the stack. So we know now that we need to have our start and stop. All right. So in between this now, we are going to write the operation that needs to take place. All right. So the first thing you're going to do now is that you are going to put the data type for whatever it is that it's going to be. So int data, that's what it is. And any data type, any variable name can go here, right? So remember we said before for our previous question that if it is that you are adding to a stack, you will have to first check or have some measures in place to check if it is that the the stack is either empty or full, right? If we're popping, we're removing. So now we're going to have an if statement. And if you check your book, you'll find that this is the same thing that you have. So if top equal, that's total equality, -1. And we know we don't use then in C. That's our condition. We're going to check if the top equal -1. Right? So if it equal -1, then our data, which is what we're going to add. So data equal 6. And any data you can add here, it's up to you, right? Else, else, item, no, sorry, data equal stack. I'm going to explain it shortly. Let me just write it out because I know you guys on C code don't work well, you know. Alright, so let me fix this. Mhm. Alright. Alright, so let's explain this 8 marks now. Let's explain this 8 marks here, as I was saying before. So first thing, we have int, which is the data type for whatever value you're going to return. In this case, it would be data. The name of our function, which is pop, because that is what the function is doing, right? The question did say that you are to accept, so represent your code as a procedure such that stack array stack is accepted as a parameter. So here it is that we have the parameter for the function, and stack is one of that parameter. That's the only parameter we were told to use. So we put the data type for that parameter, and it says that we don't know the the size of the array. It's a fixed size. So you can put in there, let's say for instance you want to put 10. It's a fixed size. So you can do that if you want. Good. Or you can leave it empty. You can put 5, you can put 4. Good. So the body of this function now, what is this function doing? So it's going to accept the data that you want to remove from the stack. Good. So let's say now, this is my stack, right? So I'm going to, these are my data. So I'm accepting data, right? That's that part. So if top equal -1, so right here, so if this equal -1, data equals 6, right? Otherwise, data equals stack top. So whatever is at the top of the stack, that should be returned. And then you're going to minus it. So which means now, if I remove this from the stack, my stack no longer, so I have 1, 2, 3, right? So if the top of my stack is 3, it means that I can't add any data to it. Good, because the stack is full. But if it is that it is not, sorry, empty. If it is that it is not, I need to remove this data from it. And if I remove data from location number 3, top should be moved to 2. Let me know if you get that part that I just said. Sorry guys, this should be 0. Sorry, this should be 0. Alright, no problem. Alright, let me clear this part and then I'll explain it again and see if we can get the concept, which I'm trying. Alright. Alright, so this is my stock. Alright. So the first part of the operation. So the bottom of the stock is -1. That's when nothing is in it. It's at -1. Remember now, this operation is removing items from the stock. So we're going to look at why it is 0. Good. So this operation is supposed to remove items from the stock. So the bottom of the stock is going to be -1. That is going to be the starting value, -1, right? All right, -1, that's what the bottom is. So if the stock equal -1, data equals 0 because we're deleting. So I can't delete from an empty stock. So that is why data going to be equal to 0. It is not going to tell me what the data is because there's no data to be removed. We get that part? So in this case where my stock is empty, if my stock is empty, data equals 0. So it's going to tell me no, there was nothing to be removed. All right. Justin, Brevet, the other persons on the live. We got that part? All right. So if now I add data to my stock, so I'm going to add this one to my stock. If I add this, top is now going to be equal to top plus 1, right? Which means that it is now at location 0. So right here, so would no longer be -1, right? This item is at location 0. If I add an X data to it, it is going to now move from location 0 to location 1. If I add an X data right here, I add an X data right here, it is going to be top plus 1, which means that it is now at location number 2. So here it is saying, no, not we. If the stock is not empty, this is what you're going to do. You are going to have data be equal to stock top. So I am going to tell you that the data that I have removed is 26 because 26 is at the top. Let's say this is 26, right? So that is this operation. Whatever value is at the top, assign it to data so that you, the user, would be able to see it. -1 plus 1 are 0. Remember that once it is that you're using an array, you start at location 0. So that is why you set it to -1 when it is blank. You don't set it to 0. Alright. So if it is now that I'm ready to delete, I'm going to delete 26. So 26 now right here. So but remember that top is pointing to number 2. So I now need to tell the system that move from location 2 and go back to location 1 because nothing are there here. So when I say top equal top, which is 2, 2 minus 1, it means now that it is the top is going to move from here and move back to location 1 because we would have deleted the top item. We're good? If it was a push operation, you do the opposite. So here now, you wouldn't want top to be equal to -1. You want top to be equal to whatever the stack top is. So if the size of the array is 10, then you would check to see if the top is equal to 10. And if the top is equal to 10, then it means that you cannot add data to it, so data would be equal to 0. Or you would return an error message to say that the stack is full. We get this? Can we move on? All right, so that was number 1. We're still on number 1. All right, moving on now to number 2. All right, good. All right, explain the function for each of the following search techniques. What is a linear search and what is a binary search? All right, linear search uses sequential searching, meaning tell the people what you mean. I want to know where the other persons. One at a time. All right. So linear search, basically it is going to search the array comparing each element against the search key. So it's going to look that which Jose would have said. So it's going to search for the key, and once it is found, then it is returned. All right, so line by line. All right, so what about the binary search now? Jackson one answering, so I ask. What about the binary search? 3 marks and 4 marks, so it's 4 marks for the binary search and 3 marks for the linear search, which means that you'd have to tell me what type it is. So a linear search is going to search the array by comparing elements in the array against the search key or the value. So whatever it is that you're looking for, if the value is found, the location is returned. So if I'm looking for 25, after I find 25 in location 8, it is going to return location 8. And it's going to compare each at a time. So this is your linear search. It is a box. Your box going to be divided up in that, right? So if it is that I am, let's say this is 6, this is 4, and this is 2. Good. 6, 4, and 2, those are the data. These are the locations. Right. So I am going to search through the data for linear search if I'm searching for number 4. So I'm searching for 4. I'm going to check here. Is 6 equal to 4? No, it is not. So I need to move on to the next location. Is 4 equal to 4? Yes. And if this is correct, then I return to you to say that it is in location 1. My thing closed. All right, 1 minute. Let me reopen it. All right, back to regular programming. All right, so that is correct, Jackson. Very good. All right, so for binary search, right? 4 marks now. So binary search uses sorted arrays. So in the example that we had before, it was sorted, but in most cases now the linear search is not sorted. So for linear search, you can have for linear search, you can have 1, you can have 6, 24, 2, 5. But for binary search, your data must be sorted. So it would be 2, 5, 6, 24. So it is sorted. So it uses sorted array. Then, as Jackson would have said, it compares the middle of the array to the key going up and down. So if it is that I am searching for 6, and right here is the middle, knowing that it is sorted, I can say, all right, then the data is not here. So the data must be in the next half. And then after that, now I'm going to divide this now into 2 again, because that is going to be half of the next 2. And then I compare it and say, all right, this is where it is, right? So the binary search now, it compares the middle of the array to the data you're looking for, right? And then if it is that it based on the value you're looking for, it will decide whether it is in the first half or the second half. And then from that, the search key, once it is greater or lesser than, it is going to return the location once the value is found. Tajmar, Brevet, Stefan, Justin. All right, good. All right, so we are moving right along. for 2b. So it says now consider the following array. So we have the array, the data, we have the location. So we have 3, 12, 9, 10, 5, and 4. Right. So write C code to store and then sort the values in the array using simple selection sort. And this is valued at 12 marks. So writing a function again, I'm going to write the function and then I will explain it. Oh no 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 no. Oh no 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 no. Oh no 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 no. Da, 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 da. And best believe this is your shortest version. All right. Mhm. Let's start. Let's start the explanation. So remember now the question it gave you the array values. So we have 3, 12, 9, 10, 5, 4, right? And it says that write C code to store and then sort the values in the array using simple selection sort. All right. So you now need to understand what is the simple selection sort. So here we have int main because it is not a function itself. You can put it in int main or you can write it as a function, whichever one. So this is the start of your function, and now we have some part right here. So we have int num. So we are telling the system the numbers that we have stored in our array. We don't need to put a value right here because once we list the values, the system will automatically realize that we have 6 values. 1, 2, 3, 4, 5, 6. 6 values and then assign the size there. So we have int num and that variable name can be anything. Then now we have oh, I think I missed something. Yeah, I missed out something. Because I was wondering why it is that I never use temp. All right. So let's go back now. So we have 4 variables here that I have declared. So I have C, I have X, I have temp, and I have small. So C is going to be my counter, right? Which is going to control my first looping structure. Right. So here I have for C equals 0. So let's say 3 is at location 0. So while for C is less than or equal to 4, do. I shouldn't have 4 here. I should have 6. 5, sorry. Right. So for C equals 0 and C is less than or equal to 5 because we're going to have 0, 1, 2, 3, 4, 5. Right. C plus plus. So here now I'm assigning small. So small equals 0. I don't know which value is the smallest number, so I'm going to give it a small digit, which is C, and C is equal to 0. Which means now that each time it compares the value and if it finds something that is greater than it, then it will align it in the correct order. So for x equals C plus 1, so C is now 1. X is greater than, less than or equal to 5, y plus plus. So we're incrementing that now. So if num y, I don't realize it's foolish this I writing. Right. So if num x is less than num small, so the first value now, if it is smaller than, if it is less than, then we're going to change the value of small from 0 to whatever the value of x is. Good. All right. Then the next part now is where we're going to switch. So we want to line up these. So 3 is the smallest value, fine. We're going to compare 3 with 12. If 3 is less than 12, it needs not move. But 12 is greater than 9, so we need to do the swapping now, where it is that we put 9 in front of 12. So this is what this is doing now. So the temp variable is equal to num c. Whatever value is in num c in that location, which in this case would be location 0. So we're taking it and we put it into temp. So we're taking, let's say 12, I will put it into a temporary file. Good. Num x is equal to num small, because we find out now that it is smaller, right? So 9 is smaller. So we're going to take 9 and we're going to assign it to num x, right? Then now we are going to switch back. So the value that we had in temp, we're going to put it back where it is supposed to be. So now your array list should look like 3, 9, 12. And that's all this part it is saying here. Who it is that I have lost? As I said, I know for sure that you guys don't do codes, or you don't like codes. Any question here, guys? Okay, Jackson. All right, let's go now. So let us do example while it is here. So we have, let's say we're doing 3, 12, 9. All right, let's say we have 12, 3, 9. All right, that's what we have in our array. Let's not look at the big picture. Let's look at the smaller part right now. All right, so we have 12, 3, 9. This now is saying, using the simple search technique, we need to arrange these three numbers in order. Good. So first now, remember that once it is that we're using arrays, we're using locations, right? So here it is that we're going to use a controller, which is our for loop, to ensure that we don't pass location 2, because otherwise there's nothing to compare it, right? In essence, this is what you're doing. You're checking now if to identify the smallest number so that the smallest number can go to the front, right? So small is going to be equal to 0, right? Or in essence, you can also set it to a higher value, whichever one. So let's compare these two now. Is 12 greater than, is location 0 greater than location 1? Yes, it is. Now, you can't just erase 12, add 3, and then add 12 around here. Good? You're going to have to utilize a temp file. Good? So let's say C is equal to 0, which is location 0 right there. So I'm going to take the data that I have. So we have location 0, we have location 1. Good. I'm going to take the data that is in location 0 and I'm going to assign it to temp. So temp is equal to 12, which means that location 0 is blank. Then now I am going to take the data that is in location 1 and I'm going to assign it to location 0. Right? So remember now, we took out 12. I'll put it in a one temporary jar. Then now we are going to remove 3 and add 3 right here. So, right? So after it is that we do that now, we have to take the data that is in temp and assign it back to location 1. So 3 would no longer be here and 12 would now be here. Good? So now these two are in order. In essence, this is what all of this is doing. So here we told the system the numbers that we have and we told them in the order that it is arranged. So it is not necessary, it is not sorted any at all. Good. So we created variables now where we're assigning small, where it is that we have a temp file, where it is that we have X and we have C. Good. Then we have our for loop, which is going to go through and check each value for that amount of time. So that that is why we have 5, because we have six values and we're starting at location 0. Good. And each time it's going to increment so that it knows when it is that it is supposed to stop. The second thing now is for the first part is for the entire thing. The second part now is just going to ensure that it moves from here and here and compare those two, right? So that you're able to compare location 0 with location 1. And depending on what is there, you assign the necessary variable or value to small. Good. Then now, once you have identified, like in this case, that location 1 is smaller than location 0, this part here is doing the switches that we would have done here in the example. Let me know if that's better. That's better. All right, good. All right, let's move on to the next part. So we're now at C. So we have 2 questions per section and then we'll be finished with section 1. The other parts are mainly definitions and so forth. I think there are 1 or 2 drawings for the next section. All right, so C now, that's our next oh, so it's asking you to list the procedures. How it is that we're looking for 16, how it is that you would identify where it is where 16 using the binary search. So binary search, as we would have said before, uses divide and conquer, right? So we have location 0 to location 9. So the first thing it is that you're going to do is that you're going to add those two. So it is it is 0 plus 9, and that is equal to 9. And then now you're going to have 9 divided by 2, because we're trying to find the middle. So we're going to get 4.5. But we're not going to pay any mind to the decimal place. So we're just going to go with the 4. Good? So let us divide now. So this is the middle. So we have 5 to 9 and we have 0 to 4. That's our middle. All right. Having identified the middle, you're going to check now. What is the middle value? The middle value is 27. So you're going to compare. Let me write. All right. So having found the middle, you're then now going to compare the value found at the middle with the value found with the value. What is it that I'm talking about? With the value you're searching for. That's what it is. So we're comparing the value found with the value you're searching for. So we have 0 to 4, 5 to 9. All right, then now. So we are looking for 16 and we found 27. So we're going to now say, is 27 greater than? So because 27 is basically greater than 16, that which we are looking for, the next step now would be to eliminate all of these. So we're not going to this side, which means, because binary search, the data in the binary search, they are sorted, as I would have said before. So we know that if we find a value that's greater, don't even bother venture that side. Now we're going to go to the first half. I'll repeat the same process now. So now it's going to be 0 plus 4. 0 plus 4 equal 4. 4 divided by 2 equal 2. So now this is the middle. Zero plus 4. Oh, it should have been here. Sorry, guys. So the first middle was actually right here, which would have been correct. We're still comparing 27. I'm just telling you what it is. So 4 would start right here and not here. It's not after the 4. All right. So now all of this out. Oops. All right. So now all of this out. So we can compare here. So right here, the error would have been where it is that I use 4 instead of 3. So it is 0 plus 3 equal 3. 3 divided by 2 is going to be equal to 1.5. And as me tell you, say, we now go right there. So right there, so we found the middle, right? So we now have 9. So then you're going to do the same thing now. We're comparing the value found with the value we're searching for. So we found 9 and 9 is less than. So because 9 is less than, and you will have to put this in writing, because 9 is less than the value you're searching for, means that you're going to eliminate these and then work on the next half. So the next half now would be 2 and 3. Repeat the same process. It's now going to be 2 plus 3, which is equal to 5. 5 divided by 2 is going to be equal to 2. So we got to location 2 now, and we are going to compare it. Is 16 equal to 16? Is it greater than, less than, whatever it may be? We found that that is where it is, and therefore it will return the location. So the calculation, the the explanation that is given, that is going to give you 2 marks each time. So that's 2. This and the explanation would give you 2. This and the explanation should give you 2. So therefore you would get the 6 marks. When you finish the paper. All right. Do I need to go over anything here? All right. We can take a 5. We can take a 5-minute break if you want, and then we would not rejoin. I'll just give you 5 minutes to go drink some water or something and come back. Let me know what it is that is your preference. A 5 minutes break, me said not lunchtime. All right, so 5 minutes break. All right, guys, take the 5 minutes now. It is now 12:25. We come back. You should be here interactive 12:30. All right, gentlemen, ready? All right, will do. That's good now. My mindset change. God, Jesus, that's stressful. All right, let's see if we can get through this. Uh, I'm not sure if you guys heard, but Odin has passed. Mm-mm. All right, guys, so let's see if I can get through this. All right. All right, so if you hear me in and out, I'm just trying to process everything all at once. Um, so state one advantage of using waterfall approach to software development. One advantage. We know that the waterfall means that one process has to be completed before it is that you reach to the next, and you cannot go back. All right, guys. All right, so state one advantage of using the waterfall approach to software development. All right, so one advantage is that it is easy to use. It is easy to use and easy to understand. Um, deliverables are provided at the end of each stage. So I gave you 2. Software development module 2. System development life cycle. All right, good. All right, so next one now. The next part of the question says to state 2 disadvantages of using waterfall approach to system development life cycle. So the fact that you cannot go back to a particular process, that's a disadvantage. No feedback is often provided to customers. That's another disadvantage. Um, ooh, right. So we can go with those two. So we have the fact that you cannot revisit the stage, a previous stage after you have passed it, and there's no feedback that is provided to customers. Oftentimes it is used when it is that you completely understand a problem. All right. Next part says describe the formal transformation model and state when it is most appropriate. So when is it supposed to be used? So once it is that the transformational process is a mathematical based technique, right? So once it is that you're using it or will hmm, once it is that any form of computation is necessary, this is the model that will be utilized, right? Um, it is used when it is that you want to go through the whole specification and verification process of hardware and software systems. When it is most useful, you're going to find that it is most useful as it relates to enforcing or enabling certain security features, reliability, coming back to the non-functional areas of a system. All right. Mhm. All right. I soon check the chat. All right, good. Then now for C, C says complete the table below by outlining one advantage and one disadvantage other than cost for each requirement gathering technique listed. So let's use up the chat now again. The paper is, I guess, because we're discussing, that is why, because it is normally 2 questions per module that you get, but eh, yeah, paper long, never mind. Paper long for sure, because they have different sections. But in terms of the time that we take to complete, it has to do with the explanations that we're doing as well. All right. One-on-one interview, what would be the advantage? Give me an advantage. Advantage of interview. Guys, please like the live. Hear viewpoints. Hear users' viewpoint. That is correct. Instant feedback. Very correct. Yeah, very good. So you get instant feedback. So you hear the person's viewpoint. You're able to grasp it. Jose, I think I would add more to that. Instead of just saying that you hear the person's viewpoint, is that you'd be able to fully understand the person's viewpoint. Because if I say something like we've been doing here, and you don't understand it, you can ask for clarifications, right? So not just don't leave it at here, but that you'll be able to understand the user's viewpoint or their requirements, etc. All right, good. So we have two disadvantage now. What would be the disadvantage of conducting a one-on-one interview? Ready? Disadvantage, guys. User might not be knowledgeable enough to understand the whole process of the development. All right, so this is a very good one. So there are times when the person you're doing the interview with, um they are not knowledgeable. So this is going to come down to the fact that it is a grand waste of time, right? So this aspect and the fact that it is would be a waste of time. Time consuming, as Brevet said first, right? So it's time consuming to complete. And the next part, which there may be bias. Um, this Justin is as it relates to software development. The bias can be there. That's true. So um, let's say for instance there's a particular way that they would want the system to be done, and because it is that you or somebody else may be providing a different viewpoint, then they may provide data which would be biased towards the way they want it to be done. So bias can work, but if you're writing something like bias, I would want you to explain it further. All right. All right, so let's look on questionnaire now. Advantage and disadvantage of questionnaire.